Good morning to one and all. I am Dr. Jaganmohan Jennalagada. So, we are in the 14th lecture of Advanced Statistical Methods. The course number is Ba Zg524. So, in the last lecture, we completed non-parametric tests as well as simulation methods. Now, in today's class, we are going to deal with forecasting methods together with time series analysis. So, in today's class, we are going to discuss time series analysis and forecast. So, what are the topics which we are going to discuss in today's class is quantitative approaches to forecasting methods, time series patterns, forecast accuracy, moving averages, and exponential smoothing. Moving averages and exponential smoothing, linear trend projection, and seasonality. So let us start with a small introduction to time series analysis and forecasting methods. So forecasting method, the name itself says that you are going to forecast a quantity or a quality or a characteristic. So forecasting methods can be classified as qualitative or quantitative. So qualitative methods generally involve qualitative methods generally involve the use of expert judgment to develop forecasts. Such methods are appropriate when historical data on the variable being forecast are either not applicable or available. So, if the historical data on the variable being forecast are either not applicable or unavailable, generally we use qualitative methods, but in this chapter we only concentrate on quantitative methods. So what are the quantitative methods which we are going to discuss, and those details will let you know. So quantitative forecasting methods can be used in the following situations. So the information can be quantified, means we should have a quantified information, and past information about the variable being forecast is available, of course, and it is reasonable to assume that the pattern of the past will continue in the future. So under these three assumptions, generally we use quantitative forecasting methods. deeply about quantitative forecasting methods and few key terms. Quantitative methods are based on an analysis of historical data concerning one or more time series. So based on the historical data concerning one or more time series, we forecast the future. What do you mean by a time series? So of course a time series is a set of observations measured at successive points in time or over successive periods of time. So a time series is nothing but collecting the data at different intervals of time or at different points of time. So if the historical data used are restricted to past values of the series that we are trying to forecast, the procedure is called a time series method. So very simple definition. A time series method means if the historical data used are restricted to past values of the series. If the historical data used, that we will deal in detail in the coming slides. So if the historical data used involve other time series also, then the procedure is called causal method, and anyhow we are not going to discuss causal method. We are going to deal with a time series in which we are using a particular time series. So we will focus only on time series methods and not causal methods in this chapter. So that's why first we discussed about qualitative and quantitative. In quantitative again we discussed causal and time series. Now we are confining ourselves to only time series methods. So that's why what is the objective of our chapter is to discover a pattern in the historical data time series and then extrapolate the same pattern into the future. So it's very simple. Based on the past observations, we are projecting the future things. So the forecast is based solely on past values of the variable and our past forecast errors. So this error term we will discuss in detail in the coming slides. So for time being, you just assume that we are forecasting the future based on the past. So finally, the outline so far is we are going to discuss forecasting methods. So there are two types of forecasting methods, quantitative and qualitative. We are only concentrating on quantitative. In quantitative, we have causal and time series methods. So causal means like we are involving more than one time series. That's what. In time series, that is the focus of this chapter, we are only considering a particular time series and we are not comparing with the others. So please just go back to the previous slides. What do you mean by causal method means? So if you are involving more than one time series data, then it may be a causal method. But if the historical data used are restricted to past values of the series that we are trying to forecast, the procedure is called a time series method. So only if we are using a past values, then it is a time series method. So now in detail we'll discuss these time series methods and forecasting methods and so on and so forth, because we are confining ourselves only to time series methods in our forecasting analysis. So please understand what we are doing here is that we have to observe the past data, and based on the past data you have to project. When we are observing the past data, we need to observe a pattern called time series pattern. based on this time series pattern only we are going to project the future. So that's why, so far somebody has asked me about a time series, so I'm just giving a detail. A time series is a sequence of measurements taken at regular intervals of time, like every hour, every day, every week, every month, every quarter, every year, or at any other regular time of interval which is prefixed. Now the interesting thing is that you have to observe the pattern in the past data. So if you are observing a pattern, maybe we expect that the same behavior can be applicable in the future also. So one of the important understandings is, like, to understand a time series pattern, we need a plot that is known as a time series plot. So to identify a interesting time series pattern, we need a time series plot. So what do you mean by a time series plot? A time series plot is a graphical presentation of the relation between the time and the time series variable. Of course it is. So on the horizontal axis will take time, and on the vertical axis will take the time series variable. So this is an example of a time series a plot where on the horizontal axis we have taken the period of time, and on the vertical axis we have taken sales. So there is a pattern available here, but we will discuss in detail. So what type of time series patterns generally we come across in these time series plots are horizontal, trend, seasonal, trend and seasonal, and cyclical. So horizontal time series pattern, maybe sometimes you may get a trend, seasonal patterns, trend and seasonal a combination, and cyclical pattern. So what do you mean by a horizontal pattern? What do you mean by a horizontal pattern? A horizontal pattern exists when the data fluctuate around a constant mean. Like suppose if the data is fluctuating around a constant mean of the data, then we observe a horizontal pattern. I'll show you the graph. So if you see the first one, it is a horizontal type of time series pattern. So it is fluctuating around a mean of the y variable. So if you observe properly, right? So changes in business conditions can often result in a time series that has a horizontal pattern shifting to a new level. To a new level means to a new average, maybe probably. So what do you mean by a trend pattern? A time series may show gradual shifts or movements to relatively higher or lower values over a long period of time. Means going to a different levels. So trend is usually the result of long-term factors such as changes in the population, demographics, technology, or consumer preferences. So a systematic increase or decrease might be a linear or non-linear. A trend pattern can be identified by analyzing multi-year movements in historical data. So the name itself says that what do you mean by trend means going to a different levels continuously. So if you go to the second graph, this is known as a trend type of pattern in the time series analysis. Why? Then we'll go back to third type is known as seasonal pattern. Seasonal patterns are recognized by seeing the same repeating pattern of highs and lows over a successive periods of time within a year. means just a repetition of same highs and same lows over a period of time. So a seasonal pattern might occur within a day, a week. A seasonal pattern might occur within a day, week, month, quarter, year, or some other interval not greater than a year. Sorry. A seasonal pattern A seasonal pattern does not necessarily refer to the four seasons of the year. Season means a repetition of highs and lows. It doesn't mean that the same repetition may occur during a spring or a summer. So maybe we have a different combination of trend and season. That's a clear picture. Sometimes a time series include a combination of a trend and season. In such a case, we need to use a forecasting method that has the capability to deal with both trend and seasonal. And finally, anyhow, with this one we are not going to deal in our lectures, cyclical pattern. Cyclical pattern, the name itself says it, repetition. So a cyclic pattern exists if the time series plot shows an alternating sequence of points below and above the trend line lasting more than 1 year. So often the cyclic component of a time series is due to multi-year business cycles. It's like ups and downs. Business cycles are extremely difficult, if not impossible, to forecast. So in this chapter, we do not deal with cyclical effects that may be present in the time series. So we are only dealing with a horizontal patterns, trend patterns, seasonal patterns. Sometimes maybe trend and seasonal, but not cyclic. So if you go to the graph, horizontal pattern means fluctuating around the mean of the variable. Trend means going to a different levels. Seasonal means repetition of ups and lows during a particular time interval. Cyclical means ups and downs over a business cycle. So like this, we have four different patterns of time series analysis. So now we have to select a forecasting method for a given time series pattern. So please remember, what do you mean by forecasting? Just take the past data, plot it, observe the pattern, and based on the pattern, select a forecasting method. So the underlying pattern in the time series is an important factor in selecting a forecasting method. Thus, a time series plot should be one of the first things developed when trying to determine what forecasting method to use. That's what I'm telling you. So if you see a horizontal pattern, we need a different method. If you see a if you see a trend or season, you may have a different method to deal with. So that's why the first and foremost important thing is that observing a pattern in the time series plot. So what few more interesting key terms we need to discuss in forecasting method, that is known as forecast accuracy. So how much accurately we are forecasting the future data. That's what an important point to deal with. So we have to measure the accuracy of forecast data. So measures of forecast accuracy are used to determine how well a particular forecasting method is able to reproduce the time series data that are already available. So measures of forecast accuracy are important factors in comparing different forecasting methods. So by selecting the method that has the best accuracy for the data already known, We hope to increase the likelihood that we will obtain better forecasts for future time periods. So the outline of the current slide is that you have to choose a best forecasting method which gives accurate results. So anyhow, in the future slides we will discuss different forecasting methods, and as well as we'll compare the accuracy by using a measures. So generally, how do you deal with a forecast accuracy? So the key concept associated with measuring forecast accuracy is the error involved in the procedure. So generally, what do you mean by forecast error? Actual value minus forecast. Actual value is only present for past data. So if you forecast the past data also with the current method, obviously you may have some error. That's what we are trying to calculate. A positive forecast error indicates, of course, right, the forecasting method underestimated the actual value. And a negative forecast error indicates the forecasting method overestimated the actual value. So the outline of this slide is that you are going to calculate forecast error for the available data or past data, and based on this you can discuss the accuracy of your method. That's what I'm telling you here. The interesting point of the current slide and the previous slide is forecasting accuracy is an interesting or an important concern in forecasting methods. So generally, by looking at time series plot, we identify a pattern, and for a pattern, we will have several methods to forecast the future data. But of the several methods, we have to choose the best. Which is the best that minimizes the error? How do you calculate error? Because for future data, we don't have an actual one. So you cannot calculate error. For only past data only, you have an actual value. So for the past data also, if you apply a forecasting method and calculate a forecast value, then you can calculate the error for the past data only. So based on the errors for the past data, you can interestingly identify the accuracy. So the at the end of the day, what I want to say, an important point is here that we will apply a particular forecast method to past data and to identify the accuracy. That's what the interesting point is. Have you come to know? Any questions in this? Yes, yes. Because forecasting accuracy only can be calculated by using the past data. For future data, we don't know the actual value. So how do you calculate the error? That's why for the past data only, we have an actual value. Again, we use forecast method to calculate a forecast value. Identify the difference between them. You will have errors. Analyzing these errors, you will have the accuracy of the method. Understood? Yeah. Any other queries? So I'll move further. So what are the measures involved in calculating forecast forecast accuracy is mean error. So mean error, the name itself says that you have to calculate the average of errors. But it is not a useful measure because some errors are with positive sign and some errors are with negative sign. Finally, they normalize the error. So the second one is mean absolute error. Absolute means you have to take the absolute value of the error and then calculate the average. That is known as what? Mean absolute error. So mean error means average of errors. Mean absolute error means average of absolute errors. Third one is mean squared error. Mean squared error means just square the errors and then calculate the average. So square the errors and average them. but the best error definition is mean absolute percentage error. Mean absolute percentage error is denoted by MAP. Mean squared error is MSE. Mean absolute error is MAE and mean error is ME. So what do you mean by mean absolute percentage error? First of all, we'll construct a absolute percentage error, and after that we will average the absolute percentage errors to calculate the mean absolute percentage error. So first of all, we should calculate absolute percentage error. After calculating absolute percentage errors, average them. So the advantage of MAP over the previous ones is it does not depend upon the scale of the data, whereas MSC and MAE depend upon the scale of the data. MAP does not depend on the scale of the data, so that's why you can easily compare different forecasting methods, because different time series data may have different time intervals. Okay, so now, we have learned many things so far. So we are interested to forecast the future based on the history. Correct? Now, in this procedure, we have to plot the history. And based on the plot, you have to observe the pattern. Based on the pattern, you need to identify a forecasting method. Before discussing a forecasting method, the interesting thing is that for every pattern you may have different methods, of which only few methods have more perfect to the situation. In what sense? By calculating the accuracy of the forecasting method. So that's why how to calculate the accuracy of forecasting method we have learned now. Now we are in the search of different forecasting methods for a given pattern. So to demonstrate the computation of these measures of forecast accuracy, we will introduce the simplest of forecasting methods. Simplest means this forecasting method can be applicable to any pattern. So generally, please remember the note point is ft plus 1 is the actual value in period t. This is the formula for the simplest forecasting method known as naive forecasting method. So what is the ft plus 1? Means you are forecasting the t plus 1th level, which is the actual value in period t. Means, like for example, you have some data in first day. To forecast the second day, we are using the first day data only. So how to forecast the t plus 1th level data, which is same as the actual value in period t. So I'm giving you an example of Roscoe drugs. Problems are very easy to solve in this method. Sales of Comfort brand headache medicine for the past 10 weeks at Roscoe drugs are shown below. If Roscoe uses the name forecast method to forecast sales for weeks, she wants to forecast for 2 to 10. Because already we have 1 to 10, but he is using forecasting 2 to 10. What are the resulting MAE, MSC and MAP values? Because we want to know the accuracy of this method. So using the past data of 1 to 10 weeks, we want to forecast 2 to 10 weeks by naive forecast method, and we want to discuss the accuracy parameters. Okay. So the first column is week 1 to 10. The second column is sales. because past data is given for 1 to 10. Now I want to forecast for 2 to 10 by using naive forecast method. So in naive forecast method, if you want to forecast the second week, we use the actual data in the first week. This we cannot do it. So similarly, to forecast the third week, we use the second week original data. To forecast the fourth week, we use the original data in the third week. Like that, we use naive forecast method. Forecast error. Do you know the meaning of forecast error? The actual minus forecasted. So 115 minus 110 is 5. 125 minus 115 is 10. 120 minus 125 is minus 5. Like that, these are the forecast errors. So if you go for this total, this is 15, 10, 15, 10, 20, 5, 0, 20. So total is 20. By how many observations? Good. 9. Because the first one is not available. So this error is known as what? Mean error. Mean error means sum of the errors by number of the observations. We have only 9 forecasts. Similarly, absolute error means what? Just take the mod of the error. Mod of the error. So 5, here also 5, here also 5. Everything we took mod. So total is 80. Total is 80. How do you calculate mean absolute error? Mean absolute error is sum of the absolute errors by 9. No, it's the 9. We don't have a first observation forecast. Please remember. Then next we'll take squared errors. 5 square, 10 square, 5 square, 5 square, like that. Total is how much? 850. So then what is mean squared error? Mean squared error is 850 by 9. Now finally, absolute percentage error. Here the logic is simple. You should remember. Yeah, there is an error here. This is 220. So this should be 9. Then this should be 9. 950 by 9. You are right. Then absolute percentage error is an important point you should remember. What do you mean by absolute percentage error? You see here, you have to subtract 115 minus 100 minus 100 means actual minus forecasted by actual. How much it is? 115 minus 100 by 115. Please calculate and tell me what is 115 minus 100 by 115. It is actual minus forecasted by actual. It is 15 by 115. Answer is, please calculate. Yeah. No. Just a moment. No. Yeah, maybe yes. There is error here. I think it should be 115 minus 100. So it's not 100. It is 110. Yeah, yeah. It's 110. Yes, it's 110. 115 minus 110 divided by 150. 115. Yeah, correct. 115 minus 110 divided by 150 is, yes. So this is 110 because here it is 115 and this is 110. So 115 minus 110 by 115 is 0.0435. Now percentage, so please multiply with 100. So you'll get 4.35. 4.35. So like that you will calculate the absolute percentages. Similarly for the next one, 125 minus 115 is 10. 10 by 125 into 100, that is 8. So like that you will calculate the absolute percentage error for each data. Then total is how much? Maybe you will get 65.35. Then Please calculate the naive forecast accuracy. So mean absolute error is 80 by 9. Mean square error, and similarly mean absolute percentage error is total absolute percentage error is 65.35 by 9, 7.26%. So then this must be 950 by 9. So this must be, this is the sum of this column, isn't it? Please check. Yeah, it is sum of the, yes, sum of the column. That's what, this is the total here, right? Then, so then you have, it's 950 by 9. So 9 ones, 950. Yes, this is the answer. Okay. So we'll move to the moving averages and exponential smoothing methods. So far we have discussed naive forecast method. Next we will discuss moving averages method, weighted moving averages method, and exponential smoothing method. So three more forecasting methods we are going to use for a horizontal pattern. So they are called smoothing methods because their objective is to smooth out the random fluctuations in the time series. They are most appropriate for short range forecasts. So how do you calculate the moving average? The moving average method uses the average of the most recent K data values in the time series as the forecast for the next period. So the recent K data values average. Each observation in the moving average calculation receives the same weight. So here we are not giving any weight. So moving average method, let us discuss in detail. The term moving is used because every time a new observation becomes available for the time series, it replaces the oldest observation in the equation. That's true, right? move as new observations become available. So whenever you are inserting new observations, the average is going to change. So to use moving averages to forecast, we must first select the order k or number of time series values to be included in the moving average. Because we have to calculate the average of k recent values, we need to determine k. A smaller value of k will track shifts in a time series more quickly than a larger value of k. If more past observations are considered relevant, then a larger value of k is better. So like if you feel that there is an impact of more past data, then you need to increase the value of k. So let us go with a 3-period moving average for the same problem. So the same question we tried Roscoe drugs. So if Roscoe drugs uses a 3-period moving average to forecast sales, what are the forecasts for weeks 4 to 11? So previously for the same problem we used name forecasting method and discussed the accuracy. Now we use moving average method with 3 periods. So first column is week. Second column is sales. Now you are calculating 3-period moving average. So please remember 3-period means the first 3 values we have to use. So that's why here you will not get anything here, here and here. Now just take the first 3, 110 plus 115 plus 125 by 3 will become the 4th observation. So to calculate the 4th observation, you have to use the previous 3 data points average. Similarly, to calculate a 5th observation, we need to use 2, 3, 4, the most 3 recent. That is, for this you will calculate 115 plus 125 plus 120 by 3. Similarly, for this you need 3 recent, means these 3. 125 plus 120 plus 125 by 3. Like that we are doing for 4 to 11 weeks. That will be given in the question. For how many weeks you have to perform will be given in the question. 4 to 11 weeks I am asking you. You have to start from 4 and you have to end up with 11. So understood? Yeah. Now for this 3-period moving average, we will discuss the accuracy. So we have the first column weeks, the second column sales, third column 3-period moving average starts from 4. We cannot take 11 here because we have only original data for 10 only. That's why I'm taking only up to 10 because we don't have 11th original data. That's why I'm not taking this. Now forecast error. So 120 minus 160.7, 125 minus 120, 120 minus 123.3. Yes, forecasting you have done, but accuracy you can do up to 10th only, because up to 10th only you have available data. Calculating the accuracy, one point if you remove is nothing, it's not a problem, right? If you are taking the average, that's why it's not a worry. So then 130 minus 121.7, like that. So the total is here 6.6. Similarly, you can calculate the absolute error. Absolute error means mod of the forecaster. Their total is this. Then you have to take the square of the errors and their total is this. Now you know how to calculate the absolute percentage error. For 4th, how do you calculate the absolute percentage error? 120 Actual minus forecasted by actual into 100. So how do you calculate the formula for this? Actual minus forecast by actual into 100. This is the formula. Yes or no? So you have calculated the total. So now let us discuss the details. Mean absolute error is how much? Total is 53.3 by how many? Yes, yes. So how many we got only? How many points we are considering here? They are how many in number? 7 only. So that's why 53.3 by 7. That is given by 7.61. Mean square error is 69.9. And mean AP is 44.22 by 7. That is 6.32. So if you compare with the naive forecast methods, in naive forecast methods you see MAE is 8.89. MAE is 8.89. In naive, MAE is 8.89 and this is 105.5. So which error is low? Of course, 3-period moving average has a low MAE, a low MSC, obviously a low MAPE also. What is the MAPE there? 7.26. 7.26. So compared to naive forecasting method, MAE, MSC and MAP is low. So 3-period moving average is better than the naive forecasting method. Right? Now we'll discuss weighted moving averages. Now actually I want to pose a question. For the same problem you repeat 4-period moving average and check which is better. Sometimes the cycle also plays a role. So if you take a 4-period moving average, it may be better than a 3-period moving average and naive forecast method. That's what I'm posing a question. I'll take a break here. I'll come back with the other method. Any questions so far?